Okay, so don't know when you may tune into this. Sometimes I think when I'm wearing this microphone, maybe we should do an interview, and I could say, okay, you two gentlemen, what are the keys to the game? I can tell my keys to the game are is here comes the ball, 3 hits, get it back over, ladies. What would be your keys to the game?
Don't make small mistakes.
Okay, yeah, don't make small mistakes. I think when it comes to marksmanship, we got a hunter over here. I don't know if you two hunt at all. Is that a really common phrase, aim small, miss small? Have you ever heard that before? So then what does that actually mean? You're looking for a small spot on the deer, like a specific spot? That means aim small?
Well, yeah, it's like if you look at a target, right?
Yes.
You're not going to aim at the entire target. You're going to aim at the very center point.
Right.
And it just happens. So if I'm like focused on, I'm like, I just need to hit the target. Then I'm going to hit the target, but it's going to be much bigger. But if I need to hit that, I might miss here, but
Okay.
I'm not. If that makes sense.
Well, it does. I think, gosh, sometimes I think, gosh, maybe I could hit that from 300 yards, but it's a lot harder than what it sounds. I know.
Yeah.
Yep. So then, okay, so 1 down, 1 to go.
Move your feet.
What are your keys to the game? Oh, that's your last name, too. We told a funny. So, okay, so move your feet. Yes, okay. So you're giving the advice to your own last name for success, right? Isn't that how we would say that? Now we got to have something to laugh about today. I mean, you two missed the other two already, don't you? I sure hope they can pick up all this sound on here. But yeah, I don't know how sensitive this microphone is. Okay, so one of the comments that I had made earlier was to Mr. Wagner. I said, I think a lot of students know. We just don't walk in here and do nothing. You've been around long enough. So all the way back from the very beginning, even when it came to describing these organic families, I've just always used a certain number of carbon compounds. And then, of course, the only thing that these 3 have in common would be what? Yeah, the parent chain is going to be 3 carbons every time. So from the very beginning, in other words, going all the way back to late August and early September, of course, our formula for propane would be C3, what? H8, okay? Because that is the formula for an alkane, because we're going to say and state why that's significant when we get down here, okay? So now we're going to add some chlorine, okay? So then the symbol for chlorine is what? So there are maybe some pitfalls or trapdoors up here. Let's see if we can navigate our way through that. So we've got this started. Now what? I mean on this side here because of this reaction, okay? All right. Okay, so there's our parent chain. Now what? Now this is a long time ago. That's why I think it's one nice thing about this type of a class. We can always go back to way long ago and review some of the concepts that you've looked, all the accomplishments that you've made. Okay, so we're still going to have what we would think is going to be that of propane, but do we have a problem right now? Yeah, there's no chlorine, but even before that, we still have a problem. There's no catalyst, that's right. Okay, so we said there's some pitfalls and trapdoors, and we could say this is one of them. So what, in your estimation, do you think would be our catalyst? You got 2 choices, and we'll put them both down. Okay, you can do heat or UV light. Okay, now that we've got that down, and this is kind of similar to that of we'll say Markovnikov's rule, but it's not the same, but we apply it the same. So that means another way we could write this diatomic molecule, of course, is Cl and Cl. So now, where would we attach one of these chlorines? And I want the major product. We don't label it as a major product. You just produce more of this. Is it the first?
Yeah, 'cause that's the easiest for it to get to.
Are we sure?
Pretty sure.
Okay. We can put one there. And then what that means then is this is really a substitution, okay? Because remember, there was a hydrogen here, so we took care of this one. This one has attached, okay? And then we still have HCl left over, but we also have another compound, but we just don't label these. So the only other place that we could or would attach a chlorine would be where? In the second one. Yep. Okay. So that is what we would call, I suppose you could say, chlorination. So we take propane, we're going to add some chlorine, we got a catalyst, and we got two distinct compounds. Okay? Kind of like if we had a spelling bee, I think who would come in first? Someone come in second. I would probably come in third, maybe fourth, I don't know. Okay, so I got third. Mr. Wagner's got fourth. Who's first? Okay. Well, just flip a coin. Your heads, your tails, huh? Heads, you win. Tails, you lose. Okay. Something, just going left to right. Okay. So, can you name that compound? You could give it two different names. They mean the exact same thing. Okay. So we can say, and you can put the one on there, but we can just do chloropropane. Or what is the derivative of 3 carbons? If you had a 3-carbon derivative on a long parent chain. Yeah. So another name you could give it is propyl chloride. This type of name does not apply to this one. Why might that be? Because it's on the second one. So we have to have something similar to this then. So the only difference that you'd have to change between these two compounds would be just saying where that chlorine is, and it's on which one. Yeah, so we have 2-chloropropane. Okay, you might notice I keep looking down at the screen. We're up to 8 minutes. We're going to do our best to not totally bore ourselves on doing some of this review. Okay, so we've got propene now. What is the only thing that has in common with propane? Okay, then how are we going to differentiate that propene from that propane? Okay, so then what is our formula for our molecular formula for propene then? Close. So that's important that this is C3H6, that's C3H8, and the reason for that is, of course, because of this double bond, we lost those 2 hydrogens, okay? Then we're adding, and I sure hope we can see that all right when we're looking at this. That's the intent, okay? Same thing, we'll just do Cl, Cl, okay? Because it's a diatomic molecule. And then one of the things we can probably go ahead and get rid of this. That might help a little bit, okay? So then we had to do something here. What about this one?
No, because those bonds break.
Yeah, these pi bonds, weak p bond, weak, they could be p bonds, yeah, I don't know. Yes, p orbital, yep. So then these bonds break very easily, and they're pi bonds, and with that, we have to be careful. What type of compound is this? Yeah, it's propene, I get that. But how did we be more specific? True. We don't have to name it, because when we go through these reactions, we said, you got to look at this. Okay? This is the asymmetrical compound, and then this is the what type of reagent? Symmetrical reagent. So with that, that's going to, again, that bond's going to break very easily. So now, if we don't change anything, we'd have propane. We know that's not right. So what happens to these two chlorines then? Remember, there's availability to bond here and here. So there must be something bonding to these two spots. These two spots here. Okay, so we're going to put a chlorine here. What about this one? Put another chlorine there. That's right. Okay. Is there anything else that we could draw with that? No, that would be it. Okay, so I'm going to just go ahead and erase all of this. Okay, that means we can erase this. Okay, now we're going to go above that, and okay, propene, still the same thing. Okay, we still have an asymmetrical compound, and water is a what type of reagent? That's asymmetrical. You can leave it as H2O, but for our purposes, and I think if it's possible, when you take this class in college, not so much this one, but general chemistry, go ahead and break this molecule apart and write it how? HOH. I don't know if that's something that your chemistry teacher taught yourself. Just go ahead and split that molecule apart like so.
I did, but it makes total sense.
Okay. And then what is the significance of having this type of setup? They're both asymmetrical, which is important. Why? Because you have a major and a minor. So, you know, I would like to think that at some point, no, you don't write plus. You're not adding them. You just get two products. At some point, I'll bet you have this very same reaction wrote down probably in 2 or 3 different spots in your notebook. Not that we're going to go back and check. Okay, we're up to 13 minutes. We want to try to wrap this up pretty soon. Okay, so your major, your minor. Okay, so that being said, where am I going with the major product or major component of this? What determines, if we're looking at that, that determines, we're kind of going opposite Markovnikovs now. So where does that OH group go if you are the major product? Exactly. That is our major product. So then, don't get this wrong. Okay? So the only thing we would say left, right, okay? And then top, bottom, middle. Okay. If we go left, right, man, it's kind of like we're marching. Left, right, oh, I'm back. Oh, no, left, nah. All right. So that is something that we learned last chapter as well. Now for what I think is, yes, this is somewhat difficult. We don't have to label these because we told you you are the major, then you are the minor. Okay. So right at about 15 minutes, we're going to wrap this up here shortly. Okay. Who's first? Okay. What am I doing? Benzene. No, they don't have to do this as often. Yeah, you can draw a good hexene structure or benzene ring. Okay. How am I going to illustrate alkylation?
We're gonna do it with the acid catalyst.
Sure? You could, but with that you need an alkene though.
No, you put a chlorine with the alkane.
Okay. So we know we need this. Okay. So now we just need, okay. And what else could you have done for alkylation? I mean, this is the simplest. We could be a little more complex if we wanted to. And if we went up even higher, C3H what? Okay, so then depending upon how many of these you want to add, the reason that that is significant is because when we're talking about alkylation, means we are adding an alkyl group, and that's what these three are, is alkyl groups. A methyl group, an ethyl group, or propyl group, even all the way up to butyl, pentyl, and I don't know. According to what looks like the research your friend does, I don't know how big that gets. Quite extensive. And what I think is significant about that is he constantly taking notes on pencil and paper?
They probably do quite a bit of that.
Okay. And the reason that we said, I can't remember if you were here, we were talking about cooking, and especially like in a crock pot. That's the easiest way to cook with things. And sometimes we just start throwing things in, and we just don't write things down, and it comes out well. What are the chances of us being able to replicate that? Probably pretty small. So that's why probably writes all that content down. Okay, here's our alkylation. So how are we going to get that methyl group attached on there? Because we need something here. Even though there's double bonds in here, this is just way too stable of a compound to not have a catalyst. Okay, we need a metal catalyst. We'll just do something like nickel chloride. So now what happens? Okay, so now we got our alkyl group on there. If we look at this now, I guess I kind of thought I'd put this up here instead of down here. And that what might have been what was a little confusing, looking at nitric acid down here. So with that, is there another way to write nitric acid? Oh no. It's a joke. Oh no. H. Oh no. I don't know why I find that funny. I just do. Okay. So this is what we're looking at. This didn't do a very good box. Called that nitration. Now, why, if this is an excess, why is that important? It's just going to keep right on going. Kind of like that Energizer Bunny. I don't see them commercials. It keeps going and going and going. Kind of like that in science. We just want to keep on going and going and going. So, all right. This determines where that's going to attach. Okay? So where's one spot that an NO2 group could attach? Okay, so we'll go here. It's in excess, so it's going to keep on going. Where else could it go? Okay, now for two reasons, okay, this is directing that to attach there, but that's not the only one, because what type of director are these nitro groups? Those are meta directors. So not only is this telling these two where to attach, once this one's on here, that's also telling that where to attach. But is there one more spot that we could go? Because this is in excess? Yeah, we can go up here, and then to make this more accurate, it's actually the nitrogen that attaches to there, and I know it looks silly, but that's how it would actually look. Okay, and then take this eraser a little bit. Why? Make that nice and big so you ladies can see it. Why is that so significant? It's dynamite, just like you ladies are going to be out there. You're going to be dynamite. See, we just proved that today. So, good job, gentlemen. All right.
Did we have an exam question on why?
You did have an exam question.
How can we do it now if we couldn't do it now? Like, didn't we have to write about how it's not possible?
Okay. It was in the question. Do we bore them with the, do I go ahead and stop, or are they going to want to hear this too?
They might.
You can probably stop. Yeah,
I'll
you
just,
can tell.
oh, okay. Tune in next time, that's what we'll say. Da-da-da! All right, we'll catch up to you next time.